Okay, we continue with the trial paper. Okay, I think we are almost at paper 1 Gen 18, I think. Good, got two paper 1 Gen 18, I think the on the top one. So I think we did halfway the day. Yeah, this one we done. Chivas, any question from this paper? Do you still have any questions? I think we've done this the day. We've done this, yeah. Have any other questions from this paper?
22.
22, 22. Okay, so deformation of solid. Okay, so loads are added to a spring that made from a material of X. A graph of force extension of the spring is plotted as shown in the diagram. Which area represents the net work done on the spring during the complete process, or net work done? You see, when you extend it, the entire work start. So P plus Q plus R is start. Okay. When you let it go, it will go down like this. So R will be recovered. R will be recovered. So what is the net work? Net means the differences lah, right? So what's the differences? That's the net work, right? You start PQR, you recovered R. So what is the net? The differences. So P plus Q. It's your net work done. In other words, yeah, this is your net work. In other words, the energy trapped, the energy trapped is got another name called net work. So answer should be P plus Q, A. Okay. So energy trap is same as net work done. The differences between the start and the recovery. Can you understand?
Yes.
Okay. Any other question? Okay. Yeah, this looks okay for you. Okay, this one, right? It depends, but okay. Okay, no other problem with the other questions. Okay, if you don't have, then we go to the next paper. Okay, go to the next paper. So paper Gen 18, we go on top. We got a paper July 17, paper 2 July 17. If you have, then you tell me, then I go to paper 1 July 17.
Teacher, I have.
Students, can you hear me?
Yes.
Yes, can.
Yes.
Okay. Okay, we open up this paper. Sorry, not this one. Yep. So July 17th. This one, right? Yeah. Any question from here? Oh, no. This is
Number 3.
this paper, is it?
Yes.
Number 3. Okay, number 3. Okay, a student carries out a series of determination of acceleration G. The table shows G is these values. What can be said about this experiment? This experiment. Uh, 9.8, 9.88, 89, 99, 92, 93, 99. Okay. Actual answer is 9.81. Right? So nothing, not even once they hit 9.81. Okay. So I will say 9.88 to 9.99. 88, 99. It is, I won't say it is accurate. It is accurate but not precise. It's not accurate and not precise.
So how do we determine how accurate it is, like in the context?
Accurate means even once you need to hit the actual value.
Okay.
It's accurate lah. Precision, they have to clarify further. They say, is it precise within 0.02 meter per second square? Is it precise within 0.03 meter per second square? They have to give that the value. But here they never tell values. So how do you find precision here? Precision. What is precision means? The what do you call the degree of consistency about a mean value. Degree of consistency among the readings. Okay, another word. What you can say? Yeah, degree of consistency lah. Degree of consistency compared to the actual value. Sorry, the mean value. So in this case, it's not to say accurate. Precision, what is the answer given?
Donkey.
Yeah. D, donkey. D,
Yeah.
definitely not accurate because not even once he hit the 9.81. But precision, they have to tell, is it within 0.02 or 0.03? That's the problem with the question. The answer is C or D. Definitely not A or B. So, yeah. 9.88. Yeah, got error in this question. They must tell precise within how much. Then only we can decide about precision. Okay. So it could be C or D.
Teacher can then can accept to answer, is it?
Exam, if they found a mistake, then we act accordingly. C and D allowed. Yeah.
Okay.
But precision, how do you calculate? You find the average. You find the average of these readings. Okay. You add and divide by 6. Then minus with. Then you check the minus with 9.88 maybe. Then 9.89. Minus with all the reading. Check how much is deviated. How much is deviated from the average value, mean value. Okay. If they say precise within 0.02, check. If any go more than 0.02, then it's not precise within 0.02. But it could be precise within 0.03. And we can say precise within 0.08. So they have to mention the which scale they're going to use. If they never mention this, difficult for us to say it is precise or not. Okay. Okay. Any other question?
Number 8.
Number 8. Okay, number 8. Let me expand this so that I can use the. Okay, number 8. Those who haven't tried, give a try. 2 marker M and M1 and M2. Set up a vertical distance of 30 centimeter apart in measuring cylinder filled with oil. Set up a vertical distance 30 centimeter apart in a measuring cylinder filled with oil. 30 centimeter apart. But here they put 90. Mistake. A steel ball is released from rest from the surface of oil point or a distance of x above the M1. It is found that the ball takes 3 seconds and 4 seconds to reach the M1 and M2 respectively. Calculate the acceleration of the ball. M1 it took 3 seconds. M1 it took 3 seconds. M2 it took 4 seconds. Okay. Problem is it 30 or 90? Okay. So 90 centimeter. This is what 90 centimeter or 90 meter given. 90 centimeter. I go for 30 centimeter. 30 centimeter look reasonable for the measuring cylinder in the lab. But it took 1 second. 3 seconds. It's a piece of oil. Okay. Possible. So just understand the technique. Go for 30 centimeter. Okay, we take it 30. So if it's 30, how do you find the acceleration? Travel here, it took 3 seconds. Travel from here to here, it took 4 seconds. So they're asking what is acceleration. Okay, how do you do this? First, consider this movement first. So S equals to ut plus half at squared. Use this. Just considering the first one, first movement. The distance travel is x. U was 0 because drop from U is 0. So therefore it's half a 3 seconds. 3 squared. First equation. Okay. So 2 unknown. We are interested in A, but x involved in that equation. We can't avoid. Yeah. So we have to look for another equation. 2 unknowns. Second equation, you take the entire movement from beginning to the end. Why choose entire movement? Because we want to make use the u equals to 0. Don't use the distance travel from M1 to M2. If you use distance from M1 to M2, this is going to be the initial, which has some value. We don't know how much. So we don't use the entire. So if you use the entire one, then it's going to be x plus what? 30 is the total displacement. It's going to be half a 4 squared. This is the second equation. So the x you substitute inside the second one. Okay, first into second equation, what happened? Half a 3 squared plus 30 would be equals to half a 4 squared. So now only one unknown. Find the a. Now you can find the a. Bring this the other side. So get half a 4 squared minus 3 squared is equals to 30. So then what do you get? Half a, what is the answer is this? 12 minus 9. 16. 16 minus 9, 7. 7 equals to 30. So 60 over 7. It's your A.
It's too large.
How much you get?
8.57.
We'll give you 8.57. Well, that means the mark scheme, they put 90 then. If you put 90, what do you get? It's going to be even bigger.
Is it going to be large? Wait, larger? Wait, no. Wait, maybe not. Let me try.
It's going to be larger. Oh, made a mistake. 30 centimeter. So 0.3. So this is 0.6. 0.6 divided by 7. What do you got?
0.09.
Oh, you got 0.09. 0.09. 0.6 divided by 7. Okay, if 0. If I 30 centimeter, I change to 90, what do you get? It's going to be 1.8. 1.8 divided by 7.
0.26. Yeah.
We've given the answer. It means the question use 90 centimeter for the answer. Okay, the error is the contradict with the value. So I think here should be 90 then to get the answer. Okay, if this comes out in exam and there is an error and not rectified during the paper, so yeah, it should be a bonus mark for one question. Okay, so this is an error, but this is the method you have to follow. Any questions?
No.
Okay. Okay, go to the
Teacher,
other
question 11.
question 11. Okay, question 11. Rod pivoted at point P on a smooth horizontal surface. The two force each magnitude of 5 Newton are applied at the two ends of the rod. The resultant torque on the rod. It's asking for the resultant torque. Resultant torque on the rod. Yeah, resultant torque. Choice is yours. You can make them. You make the force like perpendicular to the pivot. Then this force will be what? Will be 5 sine 30. This also will be 5 sine 30. Then you can use the, oh sorry, this is 2 meter, this is 3 meter. This is the pivot. Yeah, okay. Then you find the moment. The moment is the, let's say this you take it as, this is like the F1 lah. This force you take it as F2. So moment caused by F1 F1 times what? F1 times the perpendicular distance, which is 2 meter, should be plus the moment caused by this F1, clockwise, anti-clockwise, go like this one. So it's a clockwise moment. And the F2 also going like this around the pivot. This also clockwise moment. So both moment add up, the total moment. So F1 times 2 plus F2 times 3 meter. 3 meter. We'll give you the answer. So F1 is 5 sine 30 times 2 plus 5 sine 30 times 3. So altogether actually 5 sine 30 times 5 lah. So you get 12.5. Should be 12.5 clockwise. Yeah. Okay. So yeah, this is how it works. Can you understand?
Yes.
Yeah. Okay, any other question? Any questions? You got a problem here?
Teacher, question 12.
12, Okay, question 12. This is the 12, right? A diagram shows a motorized vehicle for carrying one person. The direction of motion is to the right. Okay. So the vehicle is the vehicle has two wheels on one axle. Passenger stands on a platform between the wheels. The weight is 600 Newton. Center of the mass is 200 millimeter in front of the axle. Okay. The vehicle has a two wheel. Its center of mass is 200 millimeter in front of the axle. Okay, 200 millimeter in the front of the axle. Center of gravity is 200 millimeter. Front of the axle. Front of the axle, okay, 200 millimeter front. The motor is now switched on to provide horizontal force of 90 Newton at the ground to move the vehicle forward. How far in which direction must the passenger must move his center of mass to maintain the balance? How far? His feet is acting here. The center of mass of the motor is here, 600. Oh, this question. The motor is now switched on to provide a horizontal force of 90 Newton.
Wait, so the in front, does that mean that it is how do we say it? In front of the vehicle or behind? How do you say it? Like in front of the passenger or like how is it? The center of mass.
A little contradicting with the diagram.
Because like the diagram, like does it say in front as in front of the passenger or in front of the vehicle?
When the stationary passenger 600 stands with his center of mass 200 mm behind the axle to the balance of the machine. The weight of the machine, behind the
At what position?
The weight of the pen 600 Newton stands with the center of mass 200 mm behind the axle. Behind the axle. So yeah, this is 200 mm. This will be 200 mm. Okay. And the weight of the motor is how much? 200 mm in front. 200 mm in front. Okay. At the moment, if there is no thrust exerted, this 600 and this 600 balance the system, so it won't fall down yet. But if a force of 90 Newton is applied, of course the 90 Newton will apply to the ground, this direction, okay. But the floor going to exert a force onto the axle to the 90 Newton front. Okay, this is force by ground to the wheels, yeah. Force by ground to the wheels is x to the right, Yeah. Okay. The force by wheel to the ground is to the left, right? Okay. So when this 90 Newton was applied, now the 90 Newton going to give a turning effect for this wheel, right? 90 Newton going to give a turning effect to this wheel. 90 Newton. So what is the moment caused by this 90 Newton? 90 times 400 mm. 90 times 400 mm. So now the question is, how far and in which direction must the passenger move the center of mass to maintain the balance? So tell me, this 90 times 400 mm give a clockwise movement or anti-clockwise movement? It's going to turn this way, but it's going to give a anti-clockwise movement. Anti-clockwise movement. So this weight, the weight also giving a anti-clockwise movement. Or should reduce. The center of gravity must reduce. By how much? By how much? Oh yeah. So 600 times the new position, the center of gravity must get closer. Yeah. So x get closer. X 600 times x. Yes, 600 times x. So 90 times 400 mm divided by 600. What is the x you get? Anyone? Anyone can calculate with me? 90 over 600. Oh, this is this 2, this is 3, right? So 30. How much? 60. 60?
Yeah.
Okay. So 60 mm forward. No. 60. No, you must move forward under 40 mm forward. Do you agree under 40 mm? Because this x is what? This x is the new location, the center of gravity need to be placed. New location. The old distance was 200 mm for the weight. Now the weight need to be relocated for a distance of x from the axle. Okay, from the axle you need to reduce it. Okay, you need to reduce it. So 600 times x. The x is actually the new position. New position. The new position found to be 60 mm from the axle. So originally it was 200. Now it must go to 60 new position. So how much you need to move forward? You need to move forward 140 mm forward. So answer must be D. Given D. Yes. Answer is it D.
Boy.
60 mm forward. They give 60 mm forward.
Yes.
$60 mm forward.
Just should we consider the center of mass of the motor first?
Center of mass of the motor never change. Center of the mass of the motor 602 mm away never change. They said how far in which direction must the passenger move? Center of mass to maintain the balance. It means the center of mass of the vehicle, we assume, does not change. Okay, why 60 mm? If we move 60 mm, we're going to be 140 mm away. 140 mm away. 600 times 140. This much it should be reduced. Okay. Yes. Okay. So you see, 600 times x plus 90 times 400 should be the anti-clockwise moment for the system. Should be equivalent to the clockwise moment of the axle, of the center of gravity of the axle, which is 600 times 200 mm. 200 mm, right? Yeah, 200 mm. This is the new position. Yeah, I made a mistake. This is the new position. Yeah. So find the x for this. How much you get? I think you get 140. If I'm mistaken. Please calculate this. So 600 times 200 minus 90 times 400. This entire thing is divided by 600. What do you get for the x? Come on, use your calculator. Get me the answer. $600. Somebody please calculate this. 600 times 200 minus 90 times 400 divided by 600. What do you get?
140.
Yeah, correct. Yeah, this is the correct working. Both the new position, the moment caused by the when input in the new position. This moment is the weight which is give a anti-clockwise moment. The 90 also give a anti-clockwise moment. Should be equal to the 600 times 200. So the x new position is found to be 140 mm. So he must move forward by 60. Yeah, correct. Yeah, sorry. So it should be B. Yeah, 60 mm forwards. Yeah. Okay. And answer, answer is B. You understand?
Can. Teacher, teacher, what is the moment by the ground anti-clockwise?
Moment by the ground is see, you see that this is the ground, this is the wheel. Okay, you want to move forward. It's pivoted here. The wheel rotate this way, right? Correct. Correct. The wheel going to rotate this way, but correct.
Oh,
This
yes.
way and this way. So you see this location. The wheel will move to the what? To the left. You apply a force of 90 Newton on the ground. Due to then the ground going to push it back, give an opposite force 90 Newton to the front. Okay, so the wheel exert 90 Newton force to the left. So the is action direction pair. The surface of the ground will exert the 90 Newton to the right, push to the right. Okay, push to the right. So the force will be to the right. Force by the ground to the wheel will be to the right. As I say, force by ground to the wheel is acting to the right, because force by wheel to the ground acting to the left. These two forces is an action direction pair. It's action direction pair. So if it's action direction pair, the action and reaction must act on a different direction, right? Opposite direction. Yeah. That's why it's to the right. Therefore, it makes a clockwise movement, anti-clockwise movement. Go around the pivot, is go anti-clockwise. Okay.
Okay.
Any other question? Any questions? Okay, so you go to the next paper.
Teacher, question 15.
15. This one. This is 13 or 15. This is what is this? This is 16. This is this spring, right? You're talking about?
Oh, yes.
Okay, this question. Okay, the others, come on, give a try. Mass of 30 kilogram or 3 kilogram is moving towards a spring, or 3 kilogram moving towards spring. That is neither compressed nor stretched. It is neither compressed or stretched. It's like a original shape on a rough surface. At 20 centimeter away from the spring, mass as speed of 4 meter per second. The spring has spring constant of 2 Newton per centimeter. The rough surface exerts a frictional force of 10 Newton. Oh, there's a friction of 10 Newton. Friction 10 Newton. What is the speed of the mass when the spring compression by 20 centimeter? What is the speed of the mass when the spring is compression by 20 centimeter? Compressed. The spring is compressed by 20 centimeter at this position. Okay, what speed is moving at this point? V. The block is here. Okay, how to find the speed? You have to go for conservation of energy. You can't go for kinematic. Go for conservation of energy. What energy change to what energy? kinetic energy of the, we can't say the kinetic energy. The changes in kinetic energy of the block experience changes in kinetic energy. In other words, half mv squared minus half mu squared changes in kinetic energy. Oh, sorry, we can use the work done by the thrust equals to the gain in potential energy. Here, the potential energy is the elastic potential energy plus we can use gain. Gain in EK can be used, and heat. Yeah, we can use this. Work done by the thrust is how much for this case? Is there any thrust? No thrust. So work done is by the thrust is 0. Gain in potential energy. Gain in potential energy. This is not gravitational potential for this case. This is elastic potential. So how much is the elastic potential energy gain? So half spin constant given. Yeah. Half kx squared. Okay. Plus, what is the gain in kinetic energy? Gain in kinetic energy, you can write in terms of half mv squared minus half mu squared. You can imagine like this one. We are looking for v. Okay. Plus, how much heat generated? Heat is work done by the friction. Work done against friction, sorry. So what is work done by the friction? The frictional force times the frictional force, the friction, times the distance is traveled. How much the distance is traveled from the beginning to the end? I think 40 centimeter. So x should be 40. Yeah, this is how the equation should be. Use conservation of energy. So from here you work out. Come on, you will try. So 0 equals to half. Okay, I rearrange it back. I pull out the kinetic energy, I put it to the left. So it's going to be half mu squared minus half mv squared is equals to half kx squared plus fx. Fx. Okay. So yeah, substitute and get the answer. Half m is how much? 3 kilogram. U is how much? 4 squared minus half 3. We are looking for the v squared. K is what? K is 2. How much it was compressed? Compressed for 20 centimeter. So we write in meter. So 0.2 squared. Okay. Plus with what? The friction. Friction is how much? Friction is 10. And how far? 40 centimeter. It was pushed. So 0.4. Okay. So from here, please work out your V. That should be your answer. Do you get the answer? You will try? Okay. Let me rub this. Okay, you can do it here. Yeah. So what do you got? Half times 3 times 4 squared. What do you get? 4 squared. 4 squared, 12. 12, 6, or 16, 16, 16, 8, 24. So this is 24 here. 24 minus 3 over 2v squared equals to, the other one is what? Half times 2 gone, so it's 0.04. 0.04 last bit. 10 times 0.4 squared, how much? 0.4 squared is 0.16, 1.6, 1.6. So what do you get? 1.64 minus 24 is your 3 over 2v squared minus. So what do you get? Anyone? So this, so it's going to be 24 minus 1.64. If I put 3 over 2v squared, so your v squared will be what? 24 minus 1.64 times with 203. Square root. Can you be? Anyone? What's your answer you got? 24 minus 1.64 times 2 over 3 square root. Please use your calculator, get the answer.
3.9.
I got 3.9. What is the answer given?
Yes. Answer given is C.
3.9.
So I think 0.4 don't need to square.
0.4. Oh yeah, sorry, I made a mistake. 10 times 0.4. Yeah. So 10.0.4, how much you get? 10.0.4 is 4. It's 4. It's 4, yeah. So this should be 4. 4. So 4 plus is 4.04. Yeah, 1.6, 1.64. Yeah. 4.04. Yeah, so this should be 4.04. What do you get? 24 minus 4.04 times 203. Square root, you get 3.9. 3.3 is it? How much you get?
3.6.
3.6. Yeah. So anyway, this is the method you have to use. Okay. Use conservation of energy. This works. The work done by the thrust, gain in EP, gain in EK, heat. This formula is based on conservation of energy. This works whether it's flat surface or inclined. Yeah. Okay. Okay, students. So can understand this part? Okay. So
Yes.
we stop here. I see you back later at 10 o'clock, right? Yeah. So we do more questions. Okay. Thanks.